there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, Lesson 8, Arcs and Chords. Okay, we're going to continue with arcs and chords, I guess. Classwork opening exercise. Given circle A, here's a circle centered at A, with BC, segment BC, which is a diameter because it's going through A, and DE, a chord, are perpendicular. Okay, so I'm going to stop right there and label this a right angle. FA equals 6. That is just this. Here, let me do it correctly. Let me use my segment. All right, so FA, that is right here. That is 6. AC equals 10. Okay, so let me color code that. So if you have colored pencils in your arsenal, I highly recommend using them in geometry. All right, and so now we're going to label that 10. Okay, so this is 6, this is 10, this is a right angle. All righty, so find BF and DE. All right, well, if you notice, segment BA equals BF plus FA. Agreed? Of course, because F is in the middle here. BF plus FA equals BA. There we have it. Well, AC is a radius, and that is 10. So AC equals BA. That is also a radius, so that is 10. So BA is 10. BF, we don't know. We'll just leave that BF plus FA, which is 6. So if I subtract 6 from both sides, we find that segment BF equals 4. Okay, so I will do that in red. So we found BF right there, and it is 4. All right, well, the only other thing we need to do is find the length of DE. Well, here's how you're going to do that. We're going to do another segment, so I'm going to make a triangle. Okay, so if I go from the center over to E, that is now considered a radius as well. So all radii in this circle are 10, so AE equals 10. So now I have a right triangle. Remember, we said this is a right angle because they're perpendicular. So I use the Pythagorean Theorem. So I'm going to say a squared plus b squared equals c squared. Okay, I'm a big proponent for writing formulas. Notice over here I did it, and it's just simple. It's just so simple when you use a formula and substitute givens. So now what's A? Well, A is usually opposite our smallest angle, which would be here. So A is 6. B, we don't know. That's what we're trying to find, and that's FE. So I'll just leave it B. And the hypotenuse is 10. So simplifying this, 6 squared is 36 plus B squared equals 100 squared, or 100, which is 10 squared. Subtract 36 from both sides, and we get B squared equals 100 minus 36 is 64. The square root, we then take the square root of both sides to get B. The square root of B squared is B. The square root of 64 is 8. So this segment here is 8. So DE equals DF plus FE. And we just found FE to be 8. So this is FE. So DE equals DF plus 8. Okay, unfortunately, we still have 2 unknowns, but if I drew a segment over to here, that would also be 10. and therefore we have two congruent triangles. So DF is also 8. So I'm going to erase that and I'm going to put 8 in there. Okay. So this is also 8. So DE equals 16. Alrighty, so there's the opening exercise. Okay, so before we go on to exercise 1, this is not the circle for this, as you can see in your module, if you're following along in a module. I want to explain a few things here. So this is a circle, obviously, with a point A and a point B on the circle, and a chord AB going through the circle. And then we have this arc right here. And that is being formed by the endpoints of the chord. And when we see that, what we say is that the arc AB is subtended. It is subtended by, let me see, my pen failed. All right, let me fix that. Okay, it is subtended. So arc AB is subtended by chord AB. And that just basically means that we're cutting a section of the circle off, and it is a portion of a circle with the arc included. Okay, so it's subtended. They have the same endpoints. So after I talk about that, then there's more to it than that. So let me get rid of this. Now we have this circle. So now we have arc AB right here that is subtended by chord AB. We have arc CD subtended by chord CD. So now we have two arcs and two chords. Okay, so if arc AB is the same length as arc CD, then the chords, I'm sorry, let me rephrase that. If the chords are congruent, okay, if AB equals CD, okay, then the measure of arc AB equals the measure of arc CD. Okay, I should have a comma there and a then. If AB equals CD, then the measure of arc AB equals the measure of arc CD. Okay, so if we have two subtended arcs in a circle and the chords are congruent, the arcs have equal measures. Okay, so I wanted to say that before we do this next exercise. I don't know why they didn't have an example for this, but they didn't. Anyhow, this is behind the scenes, and here we go. Here's the exercise 1. Now, with what I've told you, this is an exercise. Try doing this without seeing me do it first. So pause the video, see if you can do this, and here we go. All right, so here's a circle centered at A, so it's called circle A, with the measure of arc BC being 54 degrees. There's our given. Okay, so there's our given. Angle CDB is congruent to angle DBE. So I'm going to mark those congruent. This angle here is congruent to this angle here. That's given. Find the measure of arc DE. So here's what we're trying to find. The measure of this arc. Okay, well, keep in mind what we've learned already in this module. We have a central angle CAB, CAB, angle CAB. And since it is intercepting an arc, then the angle is congruent to the arc. So this angle, I'm just going to write facts here. The measure of angle CAB equals the intercepted arc. So therefore, the measure of angle CAB is 54 degrees. That's right here. Okay. Well, now look and you will see that, let's use orange for a change. CD, chord CD and chord BD form angle CDB, which is an inscribed angle, which is half the intercepted arc. So then I will say, let's switch back to blue, the measure. Struggles are real sometimes. Okay. The measure of angle CDB, which equals, as it's given here, the measure of angle DBE equals 1/2 this intercepted arc. So notice CEB, which is congruent to CDB, share that intercepted arc of 54 degrees, and half of 54 is 27 degrees. So this is 27, this is 54, and this is 27. Okay. So what next? What else can we get from this? We have two angles that are inscribed in the circle. They're equal to half that intercepted arc. Fantastic. The center is equal to that intercepted arc, but we still have not found the measure of angle DBE. And we need that angle measure to find this. But then you say, wait a minute. Yes, we do, because DBE is equal to CDB. I marked the wrong angle. DBE. Ay caramba. All right. I put the 27 in the wrong place. I've got the arcs in the right place, these little red ones. This is 27 degrees because we were told CDB is congruent to DBE right there. So this is 27, not this one down here. This is also 27 because it shares that 54. This is also 27 degrees, so that is an isosceles triangle. All right, but this 27 is half this intercepted arc, so 27 times 2 is 54 degrees. So there's the measure. So then here we would say the measure of arc DE equals 54 degrees. Okay, page 2. Before we get on to the next exercise, I want to give this diagram to you. And you should probably copy this. So you would need a compass to make a circle and then a straight edge. So what this is a circle called A, circle A, and it has two chords that are parallel. BC is parallel to DE, two parallel marks. The chords are cutting these arcs, and the arcs appear to be congruent, but we want to make sure. So here's what I'm going to do. I'm going to take my compass and I'm going to draw a perpendicular. Okay, so let me move this up so I don't lose the top of my compass. I do anyway, so let's do this one first. Let's do it from down here. Put your stylus or your point of your compass on. Oh, my pen just went crazy again. Put your stylus here. I'm just trying to put it like right on that dot. Okay. And then I'm going to open it up more than halfway. What I'm doing is I'm going to do a perpendicular bisector of this chord. So I'm going to draw an arc this way and this way. I then move my compass over to the other side, and I better rotate it first or it'll be off the screen, and put it on E. And then I'm going to repeat like so. Then I take my ruler, rotate it, and line it up with my arcs, and I'm going to draw a segment straight up through. So what I've just done is drawn perpendicular bisectors. So this point right here is the center of BC, and this point right here is the center of DE, the midpoint. So if I erase my construction marks now, like so, if you were to fold this circle over, C would land on B because this is a perpendicular bisector. E would land on D, which is a perpendicular bisector. And since C lands on B and E lands on D, we have just shown that the measure of arc BD equals the measure of arc CE. Okay? So that is a theorem. So you need to remember this. If two chords in a circle are if two chords in a circle are parallel, then the chords that are in between those two parallel lines are congruent. Okay? Okay, now on to page 2. If two arcs in a circle have the same measure, what can you say about the quadrilateral formed by the 4 endpoints? Explain. So again, I'm going to get a compass out and I'm going to draw a circle. Okay, so let me put a dot at the center so I know where it is. Alrighty, and then let's switch that back to red. Let's put my stylus right on there. Suppose it would have been easier to just put a dot where the stylus was, right? And rotate around. So there is a circle centered at here. Let's call it A. If two arcs in a circle have the same measure, so if I put a dot here and put a dot here, okay, let's make them further apart. How about like right there? Well, how am I going to do another pair of dots the same distance? Well, I'm going to put my compass on one dot and rotate this over and find out how far it is away by doing this. Okay. And let me see, I'm off the page. So let me move everything over. So let me move my circle. Hello. All these different pieces. All right, so I want to move my circle over so my compass is not off the screen. And then of course, now I got to put this dot here and this dot somewhere here. Okay, so that's where we were. Draw a circle centered at A, put 2 points on the circle somewhere. Put your compass point or stylus on 1 point, open it to the other one, and I'm just going to make a teeny little mark right there. So then if I put another dot somewhere, I don't know, it doesn't matter. How about right here? And bring my compass over to that point, like so. And draw an arc here and put a dot there. Then the distance between this dot and this dot is equal to the distance between this dot and this dot. Okay, so it says if two arcs in a circle have the same measure. So here's my arc right here, and here's my other arc here. So if I called this BC, can't call it A because A is the center, BC, and call this DE, then it says if two arcs in a circle, so I'd say the measure of arc BC equals the measure of arc DE. Okay, so that's my if, that's my given. What can you say about the quadrilateral formed by the endpoint? So now I'm going to get my ruler and I'm going to connect CD. So I put a dot, my ruler on C, and I'll use green for this. I will draw a segment CD. I'll bring my ruler down here and put a holding my breath while I do this, I'm going to pass out. All right, there's the other one. And then I move my ruler up like so. Draw this segment and then bring my ruler over here and rotate and draw that segment. So there is my parallelogram. So what can you say about the quadrilateral? I shouldn't have called it a parallelogram. What can you say about the quadrilateral formed by the 4 endpoints? Explain. Well, what can we say about that? Well, if this is the same distance as that, and that's the same distance as that, no matter where we put it on the circle, this thing is just going to rotate. We're going to get parallel chords. And since we get parallel chords, and we have arcs that are congruent, they're equal in measure, then the chords that form them are congruent. So this side equals this side. So what can we say about that quadrilateral? Well, it's a trapezoid and it's isosceles. How cool is that? Okay, so now we're on to number 3. 3 says find the angle measure of CD and ED. So find the angle measure of arc CD, which is right here, and the measure of the angle that forms DE. Okay, find the angle measure. Okay, so for starters, we have a diameter. We have 2 parallel lines cut by a transversal, which is the diameter. I know this is 90 degrees. So from B, so the measure of arc BED is cut by this inscribed 90-degree angle. You double that, so that's the half the circle. So BED is 180. This 65 degrees right here is an inscribed angle. So this arc right here is twice 65, which is 130 degrees. Well, if BED is 180 and BE is 130, then I can say the measure of arc BE plus the measure of arc ED equals the measure of arc BED. Okay, BE plus ED equals BED. So I write the formula, substitute in the givens. BE is now 130. Well, it's not really a given, but we learned that from prior lessons. The measure of ED is what we're trying to find, so I'll leave that there. And that is going to equal BED, which is 180 degrees. So when I subtract 130 from both sides, I find the measure of ED, and that is 50 degrees. So this is 50 degrees. ED is 50 degrees. All right, so now I got to find the measure of CD, which is right here. Well, we have parallel lines. So therefore, if I have a chord here, let me use a different color. Let me use blue. Remember, if you have a chord and then you have another chord over here, okay, and they're cut by parallel lines, parallel chords, then the arc in between those parallel chords, which we just said, I've just shown you, are congruent. So if BE is 130, CD is 130. So we're done. The measure of CD equals 130 degrees. Okay, and then therefore this would have to be 50 over here, and always check. 130 plus 50 is 180, plus another 50 is 180, 230. And 230 plus 130 is 360, and that is 360 degrees. Okay. Okay, number 4. The measure of CD equals the measure of ED, or CB. Arc CB equals arc ED. So I'm going to mark that. This equals this. That was given. Always label your givens. The measure of BC to BD to EC is 1 to 2 to 4. So BC is 1. BD right here is a ratio of 1 to 2, and EC is this large arc over here, and that is 4. Everybody follow that? BC is 1x, BD is 2x, and EC is 4x. Well, CB and DE are both equal, so now I can say DE is also in a ratio of 1. Okay, so there are our values. Find the measure of angle BCF. Angle BCF is right here. So the first thing I need to do is find the lengths or the measures of these arcs. Okay, so I know that x plus, I'm just going around starting here, going around in a circle clockwise, x plus 2x plus this x here plus this 4x here is a complete rotation of a circle, which is 360 degrees. So x plus 2x is 3x plus another is 4x plus another 4x is 8x equals 360 degrees. Divide both sides by 8 and we get x equals, 8 goes into 36, 8 times 4 is 32 with a remainder of 4, and 8 goes into 45 times. So x is 45 degrees. So this is 90 degrees. This is 45 degrees, and this is 180 degrees. So if I drew a line from C to E, that would be a diameter, okay? So now I can answer these questions. So since BCD, or angle BCF is right here, and it is formed by an inscribed angle, if we continue that, purple, right here, that's the angle we're asking for in part A. Well, it's an inscribed angle and it's half the intercepted arc. So the measure of angle BCF is 45 degrees. The measure of angle EDF, well, let me move my marks now. Here's E. E is right here, like so. And we're saying EDF, which would be like this. Okay, so let me shorten this to F. So now we're saying EDF. So I'm sorry, that'd be here. EDF, but I'm going to extend F to C because then I notice that it intercepts arc EC, which is 180. It's an intercepted arc, or it's an inscribed angle, I mean. It intercepts this arc. Inscribed angles are half the intercepted arc. So the measure of angle EDF has to be 90 degrees. That is a right angle. And then the measure of CFE. CFE is right here. So let me move my marks now. So now I'm looking at this angle right here, like so. CFE, well, that's not a central angle or an inscribed angle. So what we need to do is go back to here. And I'm going to point out to you that we have a triangle down here. And if I move this over like so, this angle right here, BED, intercepts this 90-degree angle. And so therefore, this is a 45-degree angle. And therefore, this is 45 degrees. It's a 45, 45, 90 right triangle. And then, lo and behold, we have a straight line. So it's a straight angle of 180 degrees. And E, or CFE, is right here. Well, if this is 45, this is 180 minus 45 because it forms a straight angle. That would be 135 degrees. So 45, 90, and 135. Okay, page 3, number 5. Hopefully you got the hang of this now. Another exercise. Pause the video, see if you can do it. And here we go. So it says BC is a diameter. Pause, time out. Ooh, diameter, I'm going to label that. So BC is a diameter. Well, before I even read any further, what does that tell me? Well, that tells me that arc BC, this arc over here, this whole thing here is 180 degrees. So therefore, all of this side is 180 degrees, and that's how we will answer this question. Because it says the measure of arc BD is to arc DE is to arc EC. equals 1 to 3 to 5. So it's a ratio. So it's 1x to 3x to 5x. So this is x, BD. DE is 3x. And EC is a 5x. And there we have it. Well, that's half the circle. So if this is 180 and this is 180, then to solve this, I don't even look over here yet. I'm just finding all of the arcs. And if you find everything, then you just plug your answers in when you're done. So you say x plus 3x plus 5x equals 180 degrees. And combine like terms, and 5 plus 3 plus 1 is 9x equals 180 degrees. Divide by 9 and x equals 20. Okay, so BD is 20 degrees, and DE is 3 times 20, so this is 60 degrees, and EC is 5 times 20, or 100 degrees. 100 plus 60 plus 20 is 180. So now I'm going to go over and look at what they're asking, and the measure of BD equals 20 degrees. The measure of arc DEC, so they're being a little tricky here. It's a major arc. Okay, DEC is 60 plus 100, and I'm going to write that, is 60 plus 100, which is 160 degrees. And then the measure of arc ECB. So they can ask multiple portions. And now they're asking ECB, which equals 100, which is EC, and then CB, which is 180. So the total distance from E through C around 2B is, or not distance, but the arc measure in degrees is 280 degrees. Okay, page 4 brings us to the end of lesson 8. Review the lesson summary on the theorems and go do your problem set.